Screw is a device which converts rotational forces into longitudinal linear movement. Working length of a screw is the amount of the screw which is traversing through the bone. Part of the screw is head, runout, shaft, thread, pitch, tip, flute. Head is a part where its attachment to the screwdriver helps to arrest forward motion and allow compression through the dynamic compression plate. Has conical part for countersinking or flat. It can have hexagonal to avoid slippage and better torque spread across 6 points. Can be star shaped or a cross shaped. Runout. Runout is a part of the head which allows countersinking. Transition area between the head and the threads. Weakest part of the screw. There is a shaft which dictates the bending and rotational forces. Thread determine outer diameter. Deeper threads, greater resistance to pull out. Thread depth is equal to outer diameter minus core diameter divided by 2. Pitch, distance between the thread is called pitch. Cortical screw are finer pitch. Cancellous has a bigger pitch. Tip is blunt or self-tapping. Flute is remove the bone in self-tapping screws. Sharp in self-drilling screws, which does not require a pilot hole. Lead is a distance advanced with one rotation. Bending or torsional rigidity is proportional to the fourth power of the core diameter. How to maximize pull-out strength? Larger outer diameter divided by inner core diameter. This means larger thread depth, increasing outer diameter, reducing the inner diameter, more threads, locking screws, longer screws. All these can improve the pull-out strength. Type of screw: cortical screws, cancellous screws. Cancellous screws do not remove the bone but pushes it away. Bolt screw for rotational stability. If, for example, in IM nail, small threads doesn't need pull-out strength. Suture anchors. Suture anchors are used where inadequate soft tissue makes it impossible to perform a direct soft tissue to bone repair. Type of suture anchor are screw-in anchor and interference anchor. Screw-in anchor will have threads, while interference anchor would need to be hammered. Locking screws require resistance to bending and relative small pull-out strength. Acts as an internal external fixator. Herbert screws are differential pitch with coarse pitch distally, advancing more than proximal part end of the screw at each turn. They are cannulated. Low thread depth result in decreased pull-out strength. They are self-tapping, self-drilling, double pitch, and headless. Mechanism at which the screw is placed. Positional screw or a compressional screw. Positional screw is, for example, syndesmotic screw. Lagging can be done by lagging a technique or lagging a design. Design means using partially threaded screws. They are positioned at 9 degrees at the fracture site. Other way is by technique. By technique, what you can do is first drill 4.5 mm near cortex, then place a drill guide, place it snugly, fracture remember to be reduced, then use 3.2 drill for the drill the far cortex, then do a countersink, which makes the platform for the head to be fitted and contact and have good force distribution. Failure to countersink, you have eccentric loading with reduced compression, or head may enter the medulla. Measure, depth gauge, longer than shorter is important. The tip should be away. Then tap by 4.5. Don't tap the pilot hole and place a 4.5 mm screw. Regarding countersink, it increases surface area to reduce stress. Only in cortical bone. Countersinking cancellous bone will leave soft bone which is less able to resist stress. Instead, in cancellous bone, you use a washer. Ratio of the length of the fracture divided by diameter of the bone should be at least 2:1. Lag screw is weak against shear and bending forces. That's why you have to add neutralization plate. Washer acts as a one-hole plate to improve compression and spread loads applied by head.